In this video, we're going to be graphing linear equations. In order to graph a linear equation, we need 2 points. And basically, we're going to make 2 points on a graph and we're going to draw a straight line through them. However, most of the time, if we're given an equation, we're going to be given 1 point and a slope, and we're going to use that slope to find a second point. So let's look at this first example. We have y equals 4 minus 3x. So here we have an equation, the y is alone. So this equation is in slope-intercept form, meaning it's in y equals mx plus b form. And you might see just by me writing that slope-intercept form above our equation that our terms do not correspond. So for instance, my negative 3x comes second in my equation here, not first. Well, I could just rewrite this as y equals negative 3x plus 4, taking care that the sign in front of each term comes with that term when I rearrange it, so the 3x is negative, the 4 is positive. So now you could see that these terms match up. And my slope is negative 3, and my y-intercept is positive 4. So my y-intercept of positive 4 means I have a point at 0, 4. So let me mark that on my graph, 0, 4. And from that point, I'm going to use my slope to find other points. So my slope of negative 3 means negative 3 over 1. I'm going to write it as a fraction because my numerator tells me my change in y and my denominator tells me my change in x. And on a graph, change in y, remember, we could think of that as our rise, and x is our run to the right. So from my point of 0, 4, I'm going to rise negative 3, meaning I go down 3, 1, 2, 3, and I'm running 1 to the right, and I'm going to put a point. Okay, so that point right there is the point 1, 1. That's my second point. Now that's enough to draw a straight line through. I like to find a third point just to ensure that my line is nice and straight. So I'm going to go down again from that point where I left off, run 1, put another point, so that's the point 2, negative 2. And now I'm going to draw a straight line through that, or through those 3 points. Then I'm going to put arrows on either end of that line to show that it goes forever in either one of those directions. Okay, so now let's look at our second example here. So here we have an equation that is not in slope-intercept form. This is in point-slope form. Okay, so point-slope form is y minus y1 equals m times x minus x1. So point-slope form gives us a point, and it gives us a slope, the two things that we need to draw a line on a graph. Remember, we need 2 points, but given 1 point and a slope, we could use that slope to find a second point. So let's see what we can do with this. So my slope right here is negative 2/3, but I can't use the slope yet. I need a starting point. And looking at this equation, I have y1 is equal to 3. Notice the negative signs out front are exactly the same. So my point here has a y-coordinate of 3. But look at my x value. Okay, notice here that I have different signs. Okay, so I can't simply say, hey, my x-coordinate is positive 4. That doesn't actually work. What I need to do is I need to rewrite this a little bit. Let me erase some of this. Okay, so I could rewrite my equation as x minus negative 4. And now I have a minus sign which matches point-slope form. So my x-coordinate is actually negative 4. So oftentimes what I tell students is whatever sign shows up in point-slope form, it is actually the opposite of that in your point. So here it looks like -3, but your y-coordinate is actually +3. Here, your x-coordinate looks like +4, but it's actually -4. Okay, so now let's actually graph this. So we have our starting point of -4, 3. And when I say starting point, that just means the first point that we're given. So let me plot that. 4 to the left, 3 up. Okay, so that's -4, 3. And now I'm going to use my slope to find other points. So remember, this is my change in y. -2 is my change in y. +3 is my change in x. Change in y is my rise. Change in x is my run to the right. So from that point, I'm going to go down 2, run to the right 3, put a second point. So that's -1, 1. And then I'm going to do it again. I'm going to get 3 points just to ensure that I draw my straight line properly. So my third point is 2, -1. And I'm going to draw a straight line through those 3 points. Put arrows on either side, showing that it goes on forever in either direction. So the one caveat to this, which I did not put an example up here, is, let's call this part C, is an equation that does not have an x term. Say it's y equals 5. Okay, y equals 5. You know, if you want to look at this, it doesn't look like point slope form, it doesn't look like slope intercept form. This is actually in slope intercept form. Okay, slope intercept form is y equals mx plus b. But I can actually take this equation of y equals 5 and I can rewrite it. Okay, there's no x term there. It means that there's no x's. I'm going to actually say that there are no x's, but we have a +5. So now if we take a look at this equation, we have a y-intercept of 5. We have a slope of 0. Okay, so my first point is at 0, 5. My slope is at 0. Now I could rewrite that as 0 over 1. So my change in y is 0, and my change in x is 1. Okay, so let's just say, I'm going to sketch a graph right here. So my first point is at 0, 5, right there. And my slope is 0 over 1. So from that point, I'm going to rise 0, and I'm going to run 1, meaning I'm not going to go up or down, but I'm going to go to the right 1. And then I'm going to do that for a third point. I'm not going to go up or down. I'm going to run to the right 1. And here's my line. This is a horizontal line at y equals 5. So if you're given an equation that doesn't have an x term and it's just y equals a number, you end up getting a horizontal line with a slope of 0.